So as we begin to learn what the law of sines is, it's important for us to know and explain where it comes from. So we don't just use the law of sines to find missing sides, but we can actually tell and derive where the law of sine comes from and why it works. So our objective is to find missing sides of non-right triangles using the law of sines, and then be able to explain why the law of sines works. So let's start out with an explanation of where it comes from. Then I'm going to do two problems and give you guys some questions to solve on your own. So to start out this, I guess you could call it a proof or a derivation of the law of sines, we can start out with a triangle. I've labeled the vertices A, B, and C. And then to make things a little clearer, let's label the sides across from the angles, the same letter, but have them be lowercase. So side C is across from larger case angle C, side A is across from the larger case angle A. And that's how we'll notate it, similarly with the B. And it's not really news to you, but we can split, of course, a non-right triangle into two right triangles, right? And so from here, let's actually label this blue line. Let's just call it, I guess we can just call it X. So we'll just say that's X in length. And so the law of sines is just a relationship from this non-right triangle that sort of emerges. So if I say, like for example, if I wanted to know the sine of angle A, so the sine of capital A, that's going to be equivalent to opposite over hypotenuse in this right triangle that I created. So just to take a step back to make sure we're on the same page of this, we started out with just a normal non-right triangle here. These angles all add up to 180, and then I split it with this line X to make two right triangles. And so now I'm going to say the sine of A is equal to X over C. Okay, sine of A is equal to X over C. And so then that means if I wanted to kind of isolate X, figure out what X is equal to, I could multiply both sides of this side right here and this side, by C. Now remember, sine of A is just a number. So A is an angle, and when you take the sine of an angle, you just get a number. So this whole thing here just represents one number, probably going to be a decimal depending on what A is, and just kind of help us think of it that way. So I can multiply both sides by C. So C times the sine of A is equal to X. So I basically solved for X. Now, I can do the same thing, but I can do it for angle C. So I can say that angle C, or the sine of angle C, is now equal to X over A. And it's equal to X over A because if we find angle C, the opposite side is X and the hypotenuse is A. So similarly, I'll multiply both sides of this by A, and I get A sine of C is equal to X. And so you might notice, just from the, these two expressions here, we have two things that are both equal to X. And so, using substitution, we can set these things equal to each other. So I can write essentially that C times the sine of A is equal to A times the sine of angle C. Because X equals X, and this equals X, and this equals X, so these must equal each other. That's the logic behind it. And now we're almost actually to the law of sines. Just one more quick little step. If I wanted to I guess clean this up a little bit. This is one version of the law of sines right here, but the way you're going to see it is going to be where they'll divide both sides. So I'm going to divide both sides by C so that I can get rid of this C here, and then I'm going to divide both sides by A. So if I divide both sides by C, these C's cancel, and so now I've got sine of A is equal to A times the sine of C over C. But now, if I divide everything by A, so I divide everything in this equation by A, I'm going to end up canceling this A and have an A over here. So I essentially undo both the C and the A to essentially get them to the other side of the equations. And so what it leaves us with is this final, I guess you could say, statement that the sine of A divided by angle A divided by side A is equal to the sine of angle C divided by side C. Very important to differentiate between the angles and the sides. So these again are my angles. Whoops, wrong button there. Let me redraw that. So these right here are my angles, and these right here are the sides. So we've got this wonderful relationship that we can now use, and I'll show you how to apply it. But there's one more thing, and I don't want to get overly complex. Not that it's complex, but I guess I just don't want to take too much time on the proof portion. So if I was to I'll just kind of say it real quick. If I was to draw another line down here to create, I'm probably doing that kind of wrong. It'd be more like right here to form two right triangles. Let me get rid of this part. Then I could say the same thing for sine of B over side B. I could do the exact same proof for side B. So let me clear up some room here. So the overall idea here, the actual law of sines, okay? So if you're taking notes, which you should be, so the law of sines can actually be summarized into the following. The sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. Given a triangle like this, ABC, with sides opposite the angles, this law of sines becomes true. Now let's apply this law of sines to solve some problems. So I pulled this example problem that I found online just to kind of get us sort of started with how to apply this. So again, the law of sines is sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. And so this asks us to find side AC. So that would be this side right here. And to kind of keep this straight, I'm actually going to label the A and the B's and the C's. So this would be considered side A, this would be considered side C, and this would be considered side B because they're opposite of their angle. And so I'm just going to go ahead and call AC B for now, and then I'll solve for it using that variable. And so you kind of want to pick which part of the law of sines you want to use. You don't need the whole thing. So I'll just say you really only need a set of two, any set of one of these two, and you could do sine of C equals sine of A over A. So you just really need to set up a proportion. So the question becomes, well, what do we know? Well, if I was just sort of plug in everything I knew, it would kind of show me. So let's see, if sine of 22 degrees, which is side, let me make this make a bit more sense. Let me take a step back here. If I plug in sine of A, or angle A, right here, let me make this just a little bit bigger for us, okay? If I try to use sine of angle A over A, I don't really know A, right? So it's not useful to me at this moment because I really only care about B because that's the side that we're trying to figure out. But I do know C. And it looks like I don't know angle C, but I do because they told me the other two angles. So the first thing I'm going to do is I'm going to realize I need to find what angle C is. So the first thing to do is really figure out what all the angles are if you're missing two. And in this particular case, it looks like C would be 40. So I know C is going to be 40 degrees because 40 plus 118 plus 22 is 180. So now I can use this. So I can say, okay, sine of 40 degrees over side C, which is 24, is going to be equal to, and just to match this up with the law of sines, I've just said sine of angle C over side C is equal to. And then what do we want to pull in? Well, we want to figure out what B is. So let's say it's equal to the sine of B, angle B, over the side B. And so when I fill this in, I say, okay, sine of 22 degrees over B. Now I've got an equation with only one variable to solve for. And I know the sine of 40 is just a number, and I know the sine of 22 is just a number. So now I'm going to actually go about solving this. And this is actually the portion of the law that I'm using to make this work. So and I guess you may not even want to think of it as a portion of the law. Just know that the sine of an angle over the opposing side is equal to the sine of the angle over its opposing side. That's the principle. And so I'm going to go ahead and just solve for B before I calculate any of the signs. So this is going to translate into, we'll multiply, I guess we could just cross multiply for now. I guess we're advanced enough to do that. So B times the sine of 40 degrees is going to be equal to, I'm going to run out of room here, let me move this over just a bit, is going to be equal to 24 times the sine of 22. Just cross multiply, that's all I did there. Multiplied here and multiplied here. And so now, if I wanted to solve for b, I would just divide both sides by sine of 40. So I'm going to treat the sine of 40 just like a number, okay? The algebra doesn't change. So now these are going to cancel because sine of 40 is just a number, right? So now I can say that b is equal to, I'll move over here a little bit, b is equal to 24 times the sine of 22, all divided by the sine of 40. Now, this is when I would go to my calculator and start plugging in, okay, what is the sine of 22? What is the sine of 40? And then we're going to get some decimals, right? And when you do all of that, you get a number really, really close to 14. So sine of 22, for example, I can plug that in really quick. Sine of 22 is approximately 0.375. And then you would figure out what the sine of 40 is. And you'd plug in those decimals and do the calculation, the multiplication and the division. And b comes out to be right at about 14. Now it's a little bit more than 14, it's like 14.00 something, but we know that we've rounded. So it's pretty safe just to say that b is 14. So we've done something pretty amazing. A non-right triangle, we've used trigonometry to find the side of a non-right triangle. Pretty awesome. Now I do have one more example problem for you guys, but I know the video is getting long. So here's what I want to do. I want to, on the next slide, I'm going to give you a question that I want you guys to come to class with solved. Okay, so the video is going to pause and you're going to answer that question. And you're going to show me the work for it in your journal, but I'll see your responses through the Zaption. But after that, I'm going to go ahead and give one more example. So if you're struggling, you can keep watching. If you feel like you got it and you get the question right, in fact, I'll actually put 2 questions on there. So the next slide will have 2 questions. If you get both of them right, don't worry about watching the next example. If you're still struggling, go ahead and watch the next example. So go ahead and try problems 2 and 3, okay? So you're going to try to answer problem 2, show me the work for it. You're going to try problem 3, show me the work for it. The Zaption should tell you whether you get it right or wrong. The idea is too that if you're like, oh, I'm kind of there, but I'm not quite there, even if you get them right, go ahead and watch. I'm going to do one more example, but if you feel like you got it really well, you don't need to. Okay, so here's that last example I was telling you about. So again, I like to find the, that missing angle first, just so I have all the parts and pieces that I need. So I'll just go 180 and I'll subtract 63 and subtract 101 to see what that has to be, and I get 16. So I know that angle A, it's going to be kind of hard to write in there, so I'll just try a little arrow here, is 16 degrees. And so it asked me to find AB. And again, I just like to label it so it fits kind of the law. I think it just makes life for me a little bit easier. So I'm going to label this side A, I'm going to label this side B, and I'm going to label this side C. So I know that AB is equivalent to C. Okay? That's what I'm trying to find. I'm trying to find this side right down here. And so let's look at what we know. Well, we know that we've got a 9 right here for A. So I know I'm going to need the sine of A. So let's start out with that. So the sine of 16 degrees over 9 is equal to, and now we want to pick the ratio that's going to get a C. So the sine of angle C, which is 63 degrees, over side C, which is our mystery, right? That's the thing we're trying to solve for. And again, I'm going to solve for C algebraically before I calculate sine of 16 and sine of 63. I just like to do it, and it's a little bit more accurate then, because then I just put it in my calculator at the very end. So I'll go ahead and cross multiply, right? Do the cross multiplication. So 9 times sine of 63 is equal to C times sine of 16. So I'm going to divide both sides by sine of 16 so I can solve for C, because that's what I'm trying to get. So when I do that, C is going to equal, because they're going to cancel out on the right when I divide by sine of 16, 9 times sine of 63 all over, I'll give myself just a little bit more room here, all over sine of 16 degrees. And so that's what sine equals, or I'm sorry, that's what C equals, that's what side AB is going to equal. And so when I plug that into my calculator, I should get, if I'm not mistaken, it should come out to about 29.1, somewhere in that range. I know there's going to be some rounding, so let me double check that really quick. So the sine of 63 times 9 divided by the sine of 16 comes out to 29, approximately 0.09, so 29.1 is a good round. So my final answer is going to be C is approximately 29.1. And I'm hoping this is clicking for you. If you're still going, oh, it's kind of there but not quite, come into class with questions. Don't come into class and say, I have no idea what's going on, because surely you understood at least what the law of sines, not necessarily where it came from. Maybe that was lost on you, but surely you know the law of sines. Surely you wrote it down. So at least come in with that. But I'm confident the majority of you guys are going to go back and look at this thing, or go online and do additional research if you're still not comfortable with it. There's a ton of great explanations online about why the law of sines works, where it comes from. So if my explanation didn't work for you, there's plenty of other ones to go look at, and I encourage you to do so, because I know that you guys will rise to the occasion on this. All right, guys, good luck.